Hi, and welcome to episode 11 of Modulus Manufacturing's build series for the AR4 Mk3 robotic arm kit. Up to now, in the first 10 videos, we've unboxed all of the components for this kit and gone through the construction and wiring of joints 1, 2, and 3 of the robotic arm. We've wired all of this in with all of the associated limit switches and all of the motors and motor encoders wired into the control electronics box. For those videos, please go back and watch the first 10 episodes. From now, in this episode, we'll be installing the joint 4 turret at the top of the arm here, along with the joint 4 motor and the joint 5 motor, which sits behind the turret and actually rotates the smaller arm that sits at the top of the full robotic arm assembly. We're only 2 episodes away from completing all the mechanical aspects of the arm, and then we'll be finishing off the wiring in the coming couple of weeks. So watch along and you'll get to see the construction of joint 4 of the robotic arm.
Joint 4 is one of the most complicated assemblies on the arm and consists of really 2 separate sub-assemblies, being the joint 5 motor on one side of this joint 4 turret housing, connected to the joint 5 carriage, which is on the other side, or the forearm, via one single shaft that runs through the center of the joint 4 housing. This shaft rotates upon these B1616 needle bearings, which you can see being installed into the turret housing here. Make sure that they install easily. I heated the housing up to about 65 degrees Celsius, which allowed the bearings, which had spent some time in my fridge, to easily slide inside. And once the housing had cooled down, those bearings were much more firmly held within the housing block. Deviating from the AR4 Mk3 build manual, rather than install the joint 4 turret housing to the top of the arm, I instead keep it separate from the arm and open up my tap and die set, select an M4 by 0.75mm tap and the T-bar, which will then be used to tap the 3D printed joint 4 timing pulley. Securing the 3D printed J4 timing pulley in a vise, I use the M4 tap and apply quite a lot of pressure to get each hole started. Once started, the holes do tap themselves, and I'm able to tap 4 M4 by 0.75mm holes into the 3D printed PETG carbon fiber. Thanks to being printed with 100% infill, there's no chance of crushing or damaging the 3D print. Due to the presence of potentially harmful carbon fibers within the PETG plastic, and the fact that it could get into my carpet or my lungs, in between tapping the pulley on the top and the sides, I quickly vacuum off the top of the workbench before reinstalling the vise, and then I put the timing pulley vertically into the vise, ready to tap the 4 set screw holes that go around the outside and into the main joint 4 shaft. Due to the presence of the pulley teeth and the fact that there's not as much flat surface area with the timing pulley, it's a little bit more difficult to start the holes on the outer side, but once the thread is started, completing each tap is relatively easy. So we go through all 4 holes on the outside of the timing pulley, and now, as you can see, we've got this nicely tapped 3D printed pulley. In anticipation of fitting this joint 4 timing pulley over the top of the J4 shaft, I use a deburring tool, a common 3D printing tool, to create a chamfer on the inner edge of the pulley. I then use the Stanley knife to go round the inside of the pulley, where the process of threading those outer set screws has pushed excess plastic into the inside of the pulley and created small risers where the tap came out on the inside of the printed part. So using the Stanley knife, I cut off all of those risers from inside that would be interfering with the shaft, and then proceed to create another chamfer on the inside of the pulley using the deburring tool. Finally, I use the Stanley knife to cut off any of the protruded plastic, again from the process of tapping the 4 holes on the inside of the pulley, making sure that this inner surface is nice and flat, as this is where the bearing washers will sit, the bearing that presses up against the joint 4 turret housing from this side of the joint 4 turret housing. While I was cleaning up the timing pulley, I had the J4 shaft in the freezer. Cooling this down, I can line it up with that chamfer and then use my improvised rubber mallet, aka a screwdriver, to tap this shaft down into the pulley, which is between the top of the vice grips, giving it a surface to hold it in place as I push down on the shaft. I bring this down to the first hole in the shaft, but as you'll soon see, I really should have brought it to the second hole in the joint 4 shaft. When fitting the joint 4 shaft into the timing pulley, I made sure that one of the pre-threaded holes in the joint 4 shaft lined up with one of the 4 set screw holes that had been previously tapped in the outside of the joint 4 timing pulley. Using a M4x10 set screw, which you can see me measuring here, we can fit this through those 2 holes, which will mechanically lock the 2 components together, ensuring that the shaft moves at the same rate as the timing pulley. As I went to install the set screw and referring back to the build manual, I realized that the set screw actually needs to go through the timing pulley and into the second pre-threaded hole from the end of the J4 shaft. Unfortunately, this meant I had to bring the vise back onto the bench and then keep forcing the shaft down through the pulley until that second hole from the end of the pulley lined up with the joint 4 timing pulley set screw. With the 2 holes now properly lined up, we can install the M4x10 set screw, making sure to screw it all the way through so it's not protruding out where the belt's going to be in between the teeth. Once this is done, we can then go around the remaining 3 holes and install 3 M4x5 set screws. With the long side of the joint 4 shaft facing upward, we can now install the thick PRD 1625 bearing washer over the shaft and into the recess of the J4 timing pulley. We make sure that we really press down on this to ensure that it seats into that timing pulley before fitting the needle bearings over the top, and finally a much thinner TRA 1625 bearing washer. However, before we install this last bearing washer, we make sure that we put a fair amount of grease into this bearing, as it's quite difficult to get to once installed on the robotic arm. By covering it with the grease, we can then install that last bearing washer and move it around to make sure that the bearings are properly run in. At this point, we've installed the joint 4 timing pulley and the bearing on the joint 5 carriage side of the joint 4 shaft. This shaft is what is actually installed into the turret housing seen here, and why at this point we're now able to add some grease to those needle bearings which are firmly installed in the turret block. There's 2 sides to the turret housing. One, which you can see facing the camera now, has the scallop cut out of it, whereas the other side is quite flat. Focusing on the shaft rather than my terrible job applying the grease, you can see that the shaft with the timing pulley gets installed from the flat side of the joint 4 turret housing, which goes through, and then that bearing is now pressed up between the timing pulley and the turret housing. I rotate this multiple times to run the bearings in and spread the grease that was left in there. We're now moving on to the joint 5 motor side of the turret, so we bring in the J5 motor housing. As you can see here, with the joint 5 motor mount, when seen from above, there's 4 holes around the top that will go through to the motor, but crucially this one at the very top here, which is for an M3x6 button head cap screw. This is used for the timing of joint 4, and it's quite important that we secure this in here, but leave it with a couple of threads loose so that we can adjust this when it comes time to calibrate joint 4. Before installing the joint 5 motor housing for the joint 5 stepper motor, we first remove this white piece of plastic on the joint 5 motor thread. Make sure that you set this to the side, but do not lose it as we require it for a future step. When mounting the joint 5 motor housing to the joint 5 motor, it's important that we get the alignment of the timing lug correct. So I've got the wires of the joint 5 motor pointed towards me, and then the timing lug sits on the right hand side with all 4 of the mounting screws lining up. These mounting screws are M3x16 socket head cap screws. Next, we install the thin TRA 1625 bearing washers, the NTA 1625 needle bearings, and then some grease and another TRA 1625 thin bearing washer. into the recessed side of the joint 5 motor housing. It's this bearing that allows the joint 5 motor to rotate against the joint 4 turret housing. Now time to combine the joint 5 motor assembly with the overall joint 4 assembly. We do this by mounting the joint 5 motor housing to the J4 shaft using this one set screw that's exposed on the side of the shaft. It's quite important that this gets mounted to the other side from the J4 timing lug, which was that small M3x6 button head screw that we installed earlier. Viewing the joint 5 motor and the J4 turret assembly from this side, we install the first M4x10 set screw and then work our way around. So you can see that the first set screw, the one that goes into the shaft, was installed from the opposite side from the J4 timing lug, and now the remaining M4x10 set screws get installed through, pressing onto the J4 shaft. Next up, using the same size Allen key, we install 4 M4x5 set screws into the top of the timing pulley. These set screws press against the bearing race and the joint 4 turret housing, which then pulls the shaft and the J5 motor through and effectively sandwiches the turret housing between the two halves. As you can see, this holds everything firmly in place, but still allows the joint 4 to rotate upon that axis, with the joint 5 motor shaft protruding through the entire shaft. As you can see here, I'm running in the needle bearings in the joint 4 turret housing, rotating the entire shaft using the J4 timing pulley. Having constructed the joint 4 assembly off of the main arm rather than on it, we can now revert back to page 150 of the build manual and install this joint 4 assembly to the top of the main robotic arm. We use 2 M4x14 flat head screws for the center 2 holes and then 4 M4x10 socket head screws to do up the remainder around the outside. While it's quite easy to get to the top 3 screw holes, it's a little bit more difficult to access those underneath the joint 4 assembly. Fortunately, at this point we now have enough mechanical leverage to manually rotate the joint 4 assembly through joint 3 and then access the screw holes that were underneath. So installing the 2 M4x10 socket head screws and doing those up tightly, we now have installed the joint 4 assembly onto the top of the main robotic arm where it can rotate around joint 3. With the joint 4 assembly still tilted upwards by rotating joint 3, we can easily access the underneath of the joint 4 turret housing. To this, we now attach the joint 4 motor mount and limit switch contact block, which is installed using 3 M4x10 socket head screws. This block provides a nice flat surface for the joint 4 motor bracket to be attached, but also has the limit switch contact point for joint 3 in the top right. With the joint 4 motor mount attached to the bottom of the joint 4 turret housing, we can now install this 90-degree NEMA 11 motor bracket. This motor bracket was provided in the kit from Stepper Online, along with the joint 4 motor. To ensure the correct spacing between the joint 4 motor and the timing pulley on the J4 main shaft, we install a 4mm thick 3D printed spacer that's downloaded from the Anand Robotics website. There are also multiple thickness spacers available for download from the Anand Robotics website. This allows you to fine-tune the tension on your joint 4 belt, and it's very easy to 3D print this part as it's simply a square with a couple of mounting holes in it. So using this, along with 4 M3x14 socket head cap screws, we installed the NEMA 11 bracket to the joint 4 mount. We're now getting really close to the mechanical completion of joint 4 of the robotic arm. What remains is to install the joint 4 motor itself that comes with the Stepper Online kit and make sure that we have it lined up with that joint 4 timing pulley before finally installing the belt. In the official build manual for the AR4 robotic arm, it depicts the installation of the joint 4 motor happening when the joint 4 assembly is rotated to be horizontal rather than upright as seen here in the video. Personally, I found that it was much easier installing this motor when it was upright like this, installing the 4 M3x5 screws to the top of the motor. It's also worth noting that as we make our way up the arm, typically the size of the motors gets smaller as there's less mass to work with, and we can easily rotate the joint 4 assembly given all of the bearings that are in place. Importantly, at this point, to make our wiring easier in a future step, we make sure that the wires of the joint 4 motor are pointed back towards the main arm. So working my way around, I install all 4 of those M3x5 screws, and we now have our joint 4 motor installed. Removing the yellow cap that comes with the joint 4 motor from Stepper Online, I expose the joint 4 motor shaft protruding out the top. Onto this, I then fit the 10-tooth XL belt pulley, which slides over the top with the shoulder fitting all the way down to the top of the motor. I can then tighten up 2 M3x4 set screws, which I had pre-installed into the motor pulley, making it much easier to install and tighten up on the top of the assembly. Fitting the short 87XL 037 belt over the top of the J5 motor shaft, we can then put it over the top of the pulley at the top of the J4 motor and slide it over one half of the J4 timing pulley. Then, rotating the J5 motor by hand, this moves the J4 timing pulley through the main shaft and allows the belt to slide on the top. With that done, joint 4 is now complete, and I'll show you how it all looks. So there you have it, the completion of the mechanical assembly of joint 4 of the robotic arm and the installation of the joint 5 motor. I hope that you've enjoyed the video. If you found it useful, please like and subscribe to the channel, and I'll see you next week for episode 12 of the build series.